Okay guys, this video will be discussing about coordinate measuring machine and its overview. Actually, in our previous video we discussed about inspection techniques, contact type, non-contact type, and what all other parameters needed. That is like a difference between coordinate metrology and conventional metrology we have discussed, and when to use uh, coordinate metrology or conventional metrology depends on part variety and quantity, like a PQ chart we have discussed. So in this video, we'll be discussing about coordinate measuring machine and its overview. So what is coordinate measuring machine? It's electromechanical. Actually, it is an electromechanical machine usual to measure the coordinates of the product or object being measured. Okay, the coordinate measuring machine, that is what CMM, which measures what? Geometries of physical objects. If you want to measure geometry of screw jack, or you want to measure engine block, or if you want to measure some profile with multiple curvature, we can able to use coordinate measuring machine to measure the geometries of the physical object. Okay. So when it is came, when it is being developed, so actually the first CMM made in the early 1980s. 1980s in the sense, first CMM which can measure three axes completely. That is your came in the 1960s. But earlier to that, it is originated by the Scotland people, the company called Fernanti. In 1950s, they developed a two-axis CMM which utilized for 3D tracing device, used as a 3D, which uses a 3D device, 3D tracing device, the simple digital readout, which will give you XYZ data. But they used that particular CMM for measuring products. What kind of product? Military products. Because during those period, it's era for World War. So during that time only the revolution, industrial revolution started happening, like a 2.0, 3.0, all started automations, all came in that period only. Because they want like multiple components or parts or military products needs to be made very quickly. They had lots of human power, but they are involved in participating in the military or war. So they want automated, like NC missions. Hope you remember when you studied about CAD/CAM subject. In that also you might have aware about when the NC and the CNC machine started developing. Okay, during main leaf, NC was developed to like automate the process of making the same kind of object in n numbers, multiple numbers, because each and every time operator is giving that moving the tool and making the same kind of depth of cut or making numbers, same kind of drill. It is monotonous job, time-taking process, human so resources being used. So they want to avoid that. So they developed NC codes. Then they used to make military products. Similarly, CMM machine also developed to measure the product, military products during that period. Then three-axis models were developed in the later stages of 1960s. So CMM, what it do? It does having a probing system. The probing system detect discrete points on the surface of object. Okay, it will detect discrete points. For example, if you want to measure some profile, in the sense it will trace, the probing system will trace all the features, all the surfaces of that particular product. and collect multiple data, XYZ data, as a discrete points. Okay, it's a modern machine which will be useful for measuring accurate and precious measurement. Accurate, you know, which is closer to the original value, but precious measurement, you should know that precious or precision, you know that it's repetitive. So whenever you are measuring on dimension from one particular machine or particular product on a particular product or component, you should get the similar kind of data, same kind of data, not similar, same kind of data repetitively. That is what precious measurement. Then it works in the principles of coordinate measuring. How? In the sense, measurement based on collection of data points taken in a Cartesian coordinates. Okay. So what is meant by Cartesian coordinates? You guys aware that it is with the numerical values like two coordinates x and y or y and z or x and z like that. In any two coordinates, it will be giving the values numerically. It can be represented numerically. That is Cartesian coordinate. So measurement based on collection of data points taken in a Cartesian coordinates. Under this principle only CMM works. What is the primary function of a CMM? Which is to measure the actual shape. Sometimes it will be also useful for gauging purpose, similar like a conventional metrology, coordinate metrology or CMM, also useful to measure and also to gauge the components. Okay, so the primary function is to measure actual shape of your piece, compare it against the desired shape. Okay, it will be comparing with the desired shape, already available shape, and evaluate the metrological information. So, what are the metrological information in the sense, including size, form, location, and orientations? Okay, but if you consider conventional metrology, if you want to measure size, it is possible. But form measurement, you need to go for separate measurement. Location measurement, you need separate measurement. Orientation, you need separate. But in terms of CM, coordinate measuring machine, single measurement can able to provide you size, form, location, and orientation. So, single measurement with multiple output or outcome we can expect from the coordinate measuring machine. So, it is a 3D device for measuring physical geometrical characteristics. Okay, and also it will be taking readings in 6 degrees of freedom, DOF degrees of freedom. Maybe you know that what are the 6 degrees of freedom, and it will be giving you the values or readings in terms of mathematical forms. What are the 6 degrees? Maybe you know x, y, z. In x axis plus minus will be there, y axis plus minus will be there, z axis plus minus will be there. Vertical axis is your z axis. Other than that, you will be having pitch, roll, and yaw like that. Three. So totally 6 degrees of freedom you will be having. And you see, using CMM, you can able to measure it, all 6 degrees of freedom data, geometrical features or geometrical characteristics, and you can able to display that one in terms of mathematical form. We can call this CMM also industrial robot, modern industrial robot. Industrial robots also work under the same principle. Then it is comparatively more powerful metrological tool comparing with the conventional metrology, which can be the CMM machine can be controlled manually and also through computer. As I said, multiple control is there for CMM machine. One maybe manually we can able to control or using motor power or computer control or direct computer control like that. We can control that CMM, and also based on the probe only we are going to measure the data. The probe mostly attached in the vertical axis, the third moving axis, that is z axis, z axis, we can say. With that, it will be measuring simultaneously. Your x axis will be moving and y axis also will be moving. So you will be getting and pitch your roll. So totally 6 degrees of freedom. With that, you can able to measure. But probe will be attached in the third moving axis. Okay. So that particular probe will touches your component which you want to measure, and also collect discrete points, means under Cartesian coordinates it measures and give you the various coordinate points of that particular surface which we are going to measure. Now this is the basic structure diagram. Maybe I think you might have witnessed this kind of structure only in our in our RPT lab, rapid prototyping lab, where you might have witnessed this kind of CMM machine only. So it will be having few components. So mainly main structure. This main structure, which includes three axes of motion, X, Y, Z, and also rotations, all will be there. Then probing system. Here you can able to see the probing system, and you will be having data collection system and data collection reduction system, because what are all the points you are measuring, it will give you huge number of huge volume of data, but the processing not that much processing not needed. So you need a data reduction system also, that will comes under with some dedicated software, will be given by the same company who is maker, original manufacturer of this CMM machine. So this will come up with application software, machine controller, and desktop computer. You know that machine control play vital role even in CNC machine or any other machine. So what are the inputs you are feeding through the desktop or user end? You have one software. From that you are giving some input like move the probe in x-axis or y-axis or z-axis. It will be will be sent to the machine controller. Then machine controller in turn will communicate the data or convert the data according to the machine understanding way, and input signals will be given, means electrical signals will be given to that particular motors or transducers will be there. Then you can able to control that particular machine. Vice versa, if something is being measured from your for example, feedback device, if you can consider feedback. So your probe is moving in one direction in the sense the feedback needs to be given. So through machine control unit, it will reach your desktop computer. And the application software is the front end of your any CNC machine, where you can able to interact, user interaction will be there. Okay, so these are all the main. So here you have the granite base, and here you have the two bridges like a column. So this maybe we can consider as a bridge type CMM machine. Here one in this black color housing, you will be having a base, guide base. In this only you will be having the power source for motor to move in this direction. Okay, in this direction, like x-axis you can move, and this may be if this particular vertical head may travel on this bridge. So this is your y-axis, and up and down z-axis. So this end will be having the control unit or controller for our mechanical drive system available. Only one bridge, one leg of the bridge. Another leg will be simply supported. Okay, it doesn't have any power, a drive system to provide some movement. Only it will, it's like we can say like a what to say, slave. It's a kind of slave system. It will follow based on this order. This slave system will follow just. Okay, and this is the granite table, and here your desktop computer with the application software installed in that. So I think in our lab also you might have witnessed all these things, and which a CMM consists of a constant probe that can be positioned in 3D space relative to the surface of a work part, and the XYZ coordinates of the probe can be accurately and precisely recorded to obtain dimensional data concerning the part geometry. So you'll be getting dimensional data with related to the part geometry again accurately and also precisely. So this is the overall system, similar like the previous one. The same thing is represented in another way. Like a probing head will be here, work table will be there, and bridge type, two vertical columns, bridge type, it will be moving here and there. Okay, mechanical structures, and z-axis moving up and down. Okay, even here y-axis in this vertical column, this z-axis probing system, whole head can move in this axis, y-axis located here, and This is how actually the probing system will be functioning to measure some dimensions from the part geometry. For example, this is the workpiece which is going to be measured using our CMM machine. In the sense, this is the probing head will be here, and this probe will be entered with the like a circular type or a spherical ball type, sphere type or ball type probe. Okay, so this to this you want to measure. So initially, the probe head will move down the z-axis and it touches the workpiece. Then understand the initial location. Then again it will go up and move forward. Either the probe may travel or workpiece may be moved. Mostly probe used to travel. They won't touch the workpiece. For example, if the lengthy component, then table will be moved. But here it will go up and place it over here. Then you will be able to know that two different coordinates positions. Here you will be having the XYZ, X1, Y1, X2, Z1. Or here you will be having the X2, Y2, Z2. So with that difference, you can able to understand the workpiece length. So the distance between this center axis to the probing system to another one will be called as a measured length. What actually you have measured will be shown as a measured length. But the nominal health length or workpiece length is different. Why? Because the diameter involved here. Radius, actually radius two times. So diameter of this probe is involved. So once you measure the measured length obtained, then you have to subtract the diameter of the probing system or probe so that you can able to get the nominal length. So all this information needs to be fed in the application software itself. Okay, application software will be like a correcting file. It will be doing some correction or it will be automatically neglecting or subtracting the value and give you the nominal length. Okay, so as I said, the coordinate measuring machine is an electromechanical system which is designed to perform coordinate metrology. Some of the CMM in recent days coming with very good accuracy. For example, previously it came like a 1 micrometer, but now up to 10 micrometer also we can able to measure using CMM. So that much accuracy is possible through the modern CMM. That particular CMMs nowadays coming for multiple purpose. One is to do point to point measuring the point to point coordinates, or otherwise it also analyzes the continuous data points using advanced probes, touch probes. So for example, the previous slide we discussed like this one. So this is point to point. In this particular point, again it will move up and go back here and come down, again touch. Between these 2 points, what is that length, measured length? That is different. But continuous measurement. From here, constantly it will be tracing this by touching your piece. So that is what it is told. CMM are capable of measuring point-to-point coordinates, and they can also analyze continuous data points using advanced touch probes. Okay, so this is so example is SP600 and PH20 is the example for advanced probes, you can say. So here you can able to see, maybe you can guess it. What is this? This is top of engine cover. Okay, here you may be used conventional metrology to measure center to center bore distance or diameter of this internal bores or these holes are really measured. But using this advanced what to say probes, you can able to measure the accuracy of the data up to 10 micrometer level. Okay, so and also CM can measure complex geometry tolerances and deviation on manufactured parts. So complex geometry, for example, if you are making what to say, um, drill bits, you can say with a complicated profiles will be there. We can use our CMM machine to measure. Or if you are preparing blades for turbine blades, if you are considering that turbine blades will be coming with the profiles, B-spline curves, kind of things, B-spline, Bezier surfaces and all there, right? So that profile you can able to measure with a good amount of tolerances and deviations. You can able to measure using CMM machine. And what are the applications where the CMM play a vital role? Since it's many industry, just for naming few, it is used in aerospace industries. As I said, it is used for like turbine blade measurements. Because in aerospace industry, that dimensional accuracy is very very important. Form features also very very important. Gauging purpose also, even other than measuring, gauging purpose also we can able to use. So components being used in aerospace industry or automobile industry or other industry which is mentioned here, like healthcare, food processing, plastics, semiconductor, that measurement, geometrical feature measurement or geometrical requirement is very very high in this kind of industries. So usage of CMM will play a vital role in all these industries. Okay, for example, like a PCB board printing, where it is printed properly or not, you can able to check. Or in automobile industries, whether your body structure is good, you can able to measure. Or if you want to do some welding, even it's not only, as I said, it is also considered as a industrial modern industrial robot. Okay, so for example, you've done some welding, or if you've done some spot resistant welding or something with some coordinates, with this industrial robot with a three-axis rotation. How to check that quality of the weld using some means you have to use CMM machines only. Okay, so various application in each and every industry, particularly in healthcare industry and all, play role of CMM is very very high. Then other kind of roles. What are the roles? I think in this video I will be stopping up to this one. So this slide is very very important. What is the role of CMM? So multiple things which is highlighted in green is main topic, main heading you can say, a short trend, multiple features, flexibility, high unit cost, production interruptions. Okay, so what is short trend? So generally, you guys will be thinking short run or long run in the sense. So long run means continuously producing for 5,000, 10,000, or continuously running for multiple days or years or months kind of thing. Short run means maybe for 1 day or 1 hour or 1 month kind of thing. It is not the case here. What I want to say is we may be producing hundreds or thousand number of parts, but the production run is not sufficient to justify the cost of production inspection tooling. So in terms of short run, the another thing you should have is which factor is very very important. Okay, for example, any component which you are making, what is the primary factor? One of the factors is the geometrical accuracy. Okay, geometrical dimensional, not geometrical, dimensional accuracy is very very important. So if you think about that geometrical or dimensional accuracy is very very important, in the sense you have to keep that as a primary factor for your production. Once you keep that parameter, dimensional accuracy, how do you achieve the dimensional accuracy? Whether conventional metrology can, but what extent? So you have to depend on coordinate measuring machines or the coordinate metrology. So in coordinate metrology, CMM will play a vital role in that. So using CMM, if we able to achieve dimensional accuracy, even we are making 100 or 1000 or 10,000 component or 1 lakh component, we don't need to care about production cost or something, because if dimensional accuracy is there, means all product will go without any rework or something, so it will go, it will be accepted. Then multiple feature, when we have a number of features, like dimensional features also will be there, geometrical features also there. If you want to control both dimensional and also geometrical feature, CMM is playing another vital role, and it made the process very easy and also cost effective manner. Comparing with, again, it is comparing with the conventional metrology. Then that flexibility which CMM is offering to us. Okay, so either we can go with the short run, as I said, and also it can play a multiple feature purpose also. Like it may be providing dimensional and also geometrical to achieve the geometrical requirements. It has the control over us and high unit cost. So when we will be having high unit cost, for example, generally one industry is running and making multiple components, it will be checking either each and every product being needs to be checked, or randomly they are checking. Once they are checking, if the component is completely out of dimension, either it is it is very difficult to achieve, then they will be putting that one as a scrap. So loss of material cost, or time being involved to make that also gone. Okay, in time, money, workers, every investment is gone. Or sometimes you, instead of throwing it out as a scrap, you can rework a few millimeter mm only. If we remove, it can be used as a acceptable component. In the sense, you will be giving that product to the production line again, do the reworking. So reworking, in the sense, it's not coming easily. You need to schedule it properly, you need to allot some machines, manpower, toolings and all. So that also add value. So the reworking cost or scrap cost all will add on to the unit cost. So it will increase the unit cost. You can't keep spend lots of money and not adding to your unit cost. You have to add it. So once you are adding all this, unit cost will go. So end users will not accept that. So what you have to do, if you use CMM machine significantly or properly in your production system, then and there you can able to reduce the high unit cost, and you can able to provide with a less unit cost to the customer. And production interruption. So without using a CMM, if you are running production, what will happen? Sometime you will be inspecting that rework needed, then downtime of the machine will be there. So, but if you use CMM machine properly, we can able to avoid that rework time. We can able to avoid that like a downtime of the other machines, so that we can able to continuously run the production. Okay, I think we can stop in this video up to this. Next one, we can able to check types of CMM machine and how it is being classified. We can check in detail.